Variables are a very important concept when learning how to program. They allow you to establish a name that is bound to some value, and then later rebind it to new values, so we can reassign our variables to have new meanings as our program progresses. And this is important for keeping track of computations as we work through them, so we can add things up and store the intermediate results in some place in memory, and then know that that name is going to have meaning once the computation's done. So let's take a look at variables and how we can think about them. The primary purpose of variables is that they give us a means for assigning a name to some memory that we're going to need to use later. So we can refer back to some previous computation that we had completed. Once we have a variable, we can access what the contents that were in that variable, and we can load new data so that it's bound to that variable's name, such that the next time we read what is in this variable, it's been changed, right? So it's going to be a very different understanding of the idea of a variable from what you're used to in mathematics. Right? And we're going to see that the same symbols we use in mathematics have a slightly different meaning when learning variables in programming. Every variable that you wind up using is going to wind up having two important features associated with it. First, it's going to have a name. And there are some specific rules to how we can name our variables. We'll come back to those. But you can imagine a variable like age being a name for a variable. And a variable is going to be bound to an object that we know has a specific type associated with it. And we are going to try and constrain our variables such that they hold or are bound to objects of a very specific type. So we can say that here, age is going to be a variable that can be bound to integer values. Let's go ahead and try exploring this just briefly in VS Code before we look into the specific syntax details. So I'm going to pull up VS Code and start a new terminal. I'm going to make this terminal full screen, and I'm going to start up an interactive Python programming session, also known as a REPL. Right? So oftentimes we'll compute some result. We can imagine some really complex result like 1 + 1. And we've seen this already. You've looked at expressions, arithmetic expressions, and what if we wanted to actually store that result and put a name on it so that we could later reference it? Well, let's set up a variable, age, and we're going to say that age is going to specifically hold data that is typed with integer values, and we'll assign age initially, say something like 18. Okay. Very soon we'll break down this syntax exactly. We're saying the name of the variable age is declared to be an integer variable, and it's assigned 18. Right? This is what we call a statement. Notice there's no evaluated value here. We didn't see when this is evaluated, it didn't result in some expression result that's being sent to our screen in this case. We're just saying there's a statement here. We're binding 18 to the name age. Right? So if we later refer to age, and this is going to be a variable access expression, right? So this is the name of the variable we just set up. We would see that it is going to evaluate to the last value it was bound to, in this case, 18. Well, what if we tried to access a variable that we hadn't declared and initialized yet? Well, I could say something like years old. And notice that we get an error here. It says the name years old is not defined. And that's because we have not yet established a variable or something else by the name years old yet. This is an undefined name, so it has no meaning. And this is what you'll see if you accidentally do this. So we could show, just as another example, years old could be assigned, is going to be an integer variable that's assigned, I don't know, a different value, like 20, say. And so now if I say years old and I access this variable, we see that that expression is going to evaluate to the last value it was bound to, which is 20. And if I were to access the age variable again, it's bound to 18. Okay, so far so good. You've heard me say one thing that you're going to hear me say many times over, which is this equal symbol is not the equal symbol you know and love. All right, we'll come back to that, but I want you to read that and start trying to get in the habit of reading that as is bound to or is assigned a value of 20 in this case. So years old is an integer variable that is bound to a value of 20. It is not equal to 20 in the mathematical sense, and we'll see why in just a moment. So how do you use variables generally? Well, we just walked through some of these steps. So you've already seen them. First, we can declare a variable. We actually did the declaration step and the initialization step all at the same time. And so what that means is we said, hey, here's this variable, here's its name and the type of data that it's going to be associated with. And then we initialized it by assigning it or binding it its first value. So initialization is a fancy word that only means it's the first time you bind a value to a variable's name. So we've initialized it so that we can use this variable later. As you saw, if we failed to declare and initialize a variable, it can lead to errors in our program later. So you want to be very careful if you access a variable at some point in your program, always know that you've initialized it and declared it before doing so. These two steps are very frequently combined, just like we did before. When we get to stored programs, we'll see places where we might want to declare our variable separately from initializing it. We'll come back to that. Once you've declared and initialized a variable, you can access that variable by accessing its name directly. Right? So that means I want to read the last value that was bound to this variable name. And we can use this as parts of expressions, right? So just as an example, if I were to look at, well, what is age plus 1? How old will I be in 1 year? Or how old will I be in 50 years, right? And notice that age, this is a complex expression. And first, the computer is needing to evaluate, well, what is bound to the value age? Has that name been initialized yet? And what is its value if so? And then it's going to evaluate that to 18. And then we're adding 50 to it. And then this addition expression is then evaluating to 68. Notice that in doing these things, we haven't changed the meaning of age. But the next thing we're going to see in the slide deck is we actually can change the meaning of age. So notice what we're doing here. So age is assigned, let's say 19. Now, you heard me say age is assigned 19. I could have said age is bound to a value of 19. I'm not saying age is equal to 19 because previously it was assigned a value of 18, right? And so now we're saying it's assigned a value of 19. And if we were to read it, its value has been updated. So unlike in a mathematical expression, you can change the meaning of a variable as your program goes on. So a variable is not saying, when you assign it its initial value, you're not saying it's that value for the entirety of the duration of your program. You're just saying, hey, after this point in my program, this variable is going to be bound to this value, right? So we've just updated age to be 19. On the right-hand side of this assignment operator, which is this equal symbol, we could also do things like 18 plus 1. Because this is going to be an expression, and as long as that expression, its type is the same as the type of variable we're assigning to, once that expression result is calculated, it's then going to be assigned to or bound to our variable's name. Right? So we just saw how we could reassign or write a new value, rebind a new value to a variable. We'll see there are some other more specific rules about where you can access certain variables from as we start building more complex programs that have what we're going to see is called many scopes, many different places where variables can be defined separately and apart from one another. But for now, we're defining all of our variables in the REPL, and in doing so, we're using what's called the global namespace. So these will be globally available throughout our REPL program. So when you read one of these, if you wanted to be a little bit silly about it, you could read it as, henceforth, the identifier of some name shall be bound to an object of some type stored in memory, right? And so here, age is being assigned, is being declared as a variable that's going to be assigned a value of values that can only be integers, right? And when we write our programs, there's something in the background that's going to be checking over our backs and being sure that if we assign a new value or bind a new value to age, if we tried to do something else, like assign it a string value or something else, it will tell us, hey, we've got a type error. You're not going to see this in the REPL because the REPL will carry out exactly what you want it to do and it won't give any fuss. But these types of issues tend to be logical issues when you're writing stored programs. And so when you're writing a stored program, if you try and do something that doesn't match type-wise, you'll see that there are going to be errors. And we're going to be checking for this on our end as well to be sure that there aren't any type errors when your program is evaluated. So this is an idea that is called strong typing. We're using a modern Python flavor that enables us to strongly type our variables. And your programming editor, VS Code, with the plugins, is going to check over your back and make sure all of your types work out. And this is actually a really good thing, a really big benefit when you're learning how to program, because it's like a spell checker and making sure you don't have any accidental errors in the logical types that you're trying to use throughout your program. So it's like having someone look over your back and check over you. Okay, so the general form of this, this declaration statement is some identifier, colon, and then a type, where type can be the types that we've seen so far, int, float, str, bool, but also can be types that we haven't seen. And we'll continue to see many, many more types as we go through this course. There are some rules associated with how you can name your variables. These rules actually apply in many other places besides just variables. So it's not only variables we're talking about here. So I'm going to say that these are rules for identifiers, because when we get to functions and classes and some other ideas, they're also going to be named using these identifier rules. So these rules apply not only to variable names, many other places as well. And so it's important to have a little bit of a sense of how they work and what their constraints are. These types of rules tend to be true across many different programming languages as well, but each kind of has its own special cases that might be allowed or might not be allowed. So this is another thing when you're learning a new programming language, learning what the rules are for its variable names is something you might look into. So in Python, and actually in many programming languages, your variable names tend to need to either start with a letter or an underscore. And then the rules sort of relax after that, where you can have letters and underscores and also digits like 1, 2, 3, 4 after that. And so the first character is going to be important. It has to be a letter or an underscore. But then after that, you can also use digits in addition to those. You can't use spaces. And so this is a funny little problem that we run into. Well, what if I want to name a variable something that has many parts to its name, like age or year of birth? Like that's a 3-word variable name. How do I do that? Each language also has its own rules, and Python is embracive of a rule called snake casing, and it's named after, like, Python is the snake language. Snake casing is the Pythonic way of naming your variables. And so when you have a variable name that you really want to be made of multiple words, what we encourage you to do, and is standard Python, as a standard Python idiom, is to put each word one after the other, all lowercase, and put underscores between them. We'll see places where we'll use uppercase first letters later on, but for variable names, we tend to use all lowercase letters, unless they're a special kind of variable that we'll address later. So year of birth, we could write year underscore of underscore birth. You can't have spaces in your identifiers. That would look like 2 separate identifiers to the Python language. Notice we're not surrounding these in quotes. If we surrounded these in quotes, we would have a string value. We can come back and play with that. There's one other Python specific thing I need to mention, because you've already seen an example of this in a program that you've written, which is dunderscores. And I kind of love this name because it reminds me of Dunder Mifflin in The Office. But Python reserves some special variable names and sort of allows you to very easily spot these special variable names by surrounding both sides of the variable with double underscores called dunderscores. And you've seen this in the author variable, right? Underscore, underscore, author, underscore, underscore. There's not 3 underscores. There's not 1 underscore on either side. There's 2. And this dunderscore notation is just an idiom or a convention used in the Python programming language to highlight that this is a variable that we, the language, are assigning some special meaning to or have some special use case of. Or we'll see that there are places where this isn't just variables, but also the names of other kinds of things that are special to the language, and the language is assigning meaning to them. And they use these 2 underscores to just ensure that you don't accidentally overwrite something that means something special to the language, right? So you'll see a bunch more of these, like init, name, repr, and str, as we move through the course. But for now, I just wanted to highlight that this is a special kind of weird thing. This is a very Python specific idiom. And in other languages, they have similar ideas, but they'll take on different forms than this specifically. And that's another part of learning a language, is some of these special capabilities that are kind of magical behind the scenes when you learn how they work. They're going to have special names in whatever programming you go off and use next. All right, let's break down the syntax of variable assignment. So we've already seen this, but I want to just emphasize this equal symbol is not equals. We'll see equals. We've already seen equals. Equals is the double equal sign, and that's something that checks one value is whether one value is equal to another. Here we're saying age is bound to a value of 21. Age is assigned 21. Age takes the value of 21. Age is now 21. Any of those ways of reading this expression in the statement is totally fine. Don't read this as age is equal to 21, right? And it's going to take some time to get in the habit of not reading it as that because you've spent so many years of your life being taught that's how you should read something that looks like this in math. Try and force yourself to read that this variable name is bound to some new value. We're redefining what this variable name will evaluate to later, what it means in our program after this line of code evaluates. So the general form is the identifier is always going to be on the left-hand side of the expression, and then the expression itself is going to be on the right-hand side of the equal symbol. So this is important. This matters, right? So you can't flip these two things. You can't put the expression on one side and the identifier on the other. That would have a very different meaning, and it would tend to be incorrect syntax, right? And we could go try that out just to prove to ourselves that that is in fact the case, right? So if we were to try 5 equal age, notice there's a syntax error. We cannot assign to a literal. The literal that we're talking about here is the literal 5, that int literal. And we're, again, what's on the left-hand side of the assignment operator, the single equal symbol, is going to need to be a variable name. So we could say age is assigned 18 plus 2, and that's totally fine. Notice we can write an expression on the right-hand side of the assignment operator. And because we can write an expression, you know that we can do a lot of cool things here. We can make our own arithmetic, we can call other functions, we can do whatever computations are going to be expressed as an integer expression. As long as that expression evaluates down to a single integer, and that expression is typed as an integer, we can use it here on the right-hand side of the assignment statement for assigning or binding that value, that result, to age. If we were dealing with a string variable, so for example, name is a string variable that is Chris, we could also assign things like name is now going to be Michael, right? And if I access what is in the variable name, or what was the last value name was bound to, we would see that it's Michael, right? So on the right-hand side of our assignment operator, you can use any expression as long as that expression is of the same type of the variable. So name is assigned Michael plus, or concatenates with, Jordan. And remember, that's going to take those two values, can join them together to make a new string, and now name would be Michael Jordan. So that's a string expression there using the concatenation operator. The point is, you can write any expression you want on the right-hand side of the assignment operator, but the left-hand side has to be an identifier that is of the correct type to be able to hold that result and store that result. When we run a line of code like age is assigned a value of 20 or age is bound to 20, in memory, we're going to see that there's some variable that's been set up and its value will be bound to whatever we assigned to it, right? Later, we can reassign or rebind a value here, and that's no problem whatsoever, right? Because the whole point of a variable is it's going to just be bound to some place in memory, and we're trying to control what is stored in that memory or what is bound to that memory. Assignment is not equality. It's not equality. You've got to be very careful with this because you don't want to confuse these concepts. And this is initially something that I think is very difficult, having spent so many years studying math and then studying programming for the first time. This will cause you some discomfort to have to think about what the equal symbol means in a different way. But we'll get a lot of practice with it. As I mentioned, a variable's value is able to change as the program progresses on. We've seen examples of this already, right? And I'm making a comment here. I'm actually going to skip over it in the slide since I emphasized it so heavily earlier, that you can't commute the two sides of this symbol like you can in math. In math, you can flip the two, what's on either side of your equality operator, and it's fine. In programming and in most languages, you cannot. What's important is on the left-hand side. That's got to be what you're assigning to, and the expression that you're trying to compute to find as a result is on the right-hand side. We've already demonstrated this idea that after you if you try and access a name that has not yet been declared and initialized, you're going to get a name error. And that name error is going to tell you, hey, you haven't told me what this means yet. You haven't bound this name to any value in your program yet. So I don't know what to do with this. You've heard me say this before. I'm going to say it again. When you assign a value to a variable, that value's type or that expression's type needs to match the type that you declared that variable with. And this will help you avoid surprising and hard to debug issues when you get to it. These are also slides for reference. The right-hand side is an expression, and what I emphasized before is that every expression evaluates to a single value, all right? So we can write numerical expressions, function calls, and other things, right? So this is a slide mostly for reference. And I want to spend a little bit of time to talk about initialization because it is important terminology to understand, and it's fundamentally important to being able to safely write programs. You always want to initialize your variables. You never, never, never want to fail to initialize a variable because it will likely lead to an error later in your program. Once you've initialized a variable, we call that a bound variable. It's now bound to some value that has meaning that you can use later. As we saw, here's an example of how we can declare and initialize on 2 different lines of code. And there might be cases where you would want to do this in your stored programs. But typically you're going to want to do these things and you'll find yourself doing these 2 things at the very same time, right? With one caveat, and this is actually how we're going to encourage you to write your programs, especially in these early days of Comp 110. But there is a way for the programming language to be a little bit smarter about how it assigns the type to your variable name. So for example, there's a little bit of redundancy here, right? We are seeing that lucky is going to be an integer variable, and then we're immediately initializing it to be the number 13. Well, if we left this part out, right, lucky is bound to a value of 13, we're smart enough to infer that lucky must be a variable that can hold an int value, right? And so modern programming languages are smart enough to infer that as well. And so what we'll see is that once you get comfortable, you can, if you're initializing a variable as soon as you're using it, you can rely on type inference here for lucky to implicitly be or inherently be of type integer. But we're going to encourage you to be explicit about this in the early days of programming and just write your types out because it'll be easier for you to read, especially if this 13 isn't just so obvious. If this were a function call, you'd have to know exactly what type that function returned in order to know what type of variable that you're using here. So we're going to encourage you to always in the early days of this course, explicitly define the types of your variables as you're declaring them. And then as you get more comfortable and you go into later years after this course, you can rely a little bit more strongly on type inference. All right, so just a few notes there. We've talked about accessing a variable. This slide is mostly just for reference, but I want to point out one very important difference. So notice if we access the variable name, it's whatever the last value was stored in that or bound to that variable name. Age, same thing. But if we put quotes around this, notice it's the string age or the string name. And that's a very different meaning, right? That's a string literal, meaning this is the textual data age or the textual data name. That's very different from accessing a variable. And the key distinction here are those quotes that are telling you, hey, one of these things is a string literal and is textual data, and the other is an identifier. The one without any quotes is an identifier. And when we see an identifier, what we're going to do when we evaluate it is we're going to go look up what was the last value bound to this identifier. Now I want you to think about this statement for just a moment. And if this is your first time programming and you're in the early stages of your programming career, you're probably looking at this statement. And if I tell you that this is a completely valid programming statement that you'll make frequently in this course and in the future, you're probably looking at me like, that doesn't seem right. That is not okay, right? If this were an algebraic expression, this would be completely illogical. You can't have one variable that is going to be equal to that same variable plus one. Like that is illogical. This is an invalid statement in math, in algebra, right? Well, remember, this is not equality. And what we're importantly trying to emphasize here is that the equal symbol is assignment. And in order to understand how this type of statement is broken down, first, you always want to focus on what happens on the right-hand side of your assignment operator. And here we have a complex expression. We have an access, so we need to look up the last value of the name stored in age. We need to then add 1 to it. And then once that's done, we're going to take the result of that expression and then rebind age so that it means 1 plus what it was before, right? So there's a sequence of steps that's important here. And the key idea is that we're going to read this as age is assigned age plus 1. Right? We take our current value assigned to age, we read it. This is a variable access expression that's part of a bigger arithmetic addition expression. We're going to add 1 to it. The result of that is then going to be stored in rebound to age. Right? So age is going to be rebound to be 1 plus what it was before. So let's try this out just to prove to ourselves that this is possible. So age is currently 20. Age is assigned the current value of age plus 1. Notice we're rebinding age. This is a statement. This isn't actually an expression. And when I enter and access age directly again, we see that it's now 21. If I were to run the same statement one more time, age is assigned or bound to the same value it was plus 1. Age is now 22. So notice we're redefining the meaning of age relative to its previous meaning or relative to what it was previously bound to. And this takes some comfort to get used to in your early stages of programming because that statement, reading this text looks so unnatural based on what you've been trained to think of with this. And so try and unlearn some of the rules around the equal symbol that you've been taught in math. This is a fundamental introduction to variables. They allow us to bind names to values in memory to later access what was the last value that was bound to this name so we can look back up something that we previously computed. And also reassign new values. And this is going to be how we're able to compute small steps of some algorithm piece by piece and work our way towards some accumulated final result. Playing around with variables is what we'll be focused on in the next exercise. And I hope you will continue tinkering in the interactive Python shell to get a little bit more comfortable with them. Great work.